A particle moves along the x-axis so that its velocity v at time t for the closed interval 0 to 5 is given by v of t. The particle is at position x equals 8 at time t equals 0. For part A, we have to find the acceleration of the particle at time t equals 4. Keep in mind that if you differentiate the position function, you get the velocity function. And differentiating the velocity function gives you the acceleration function. We are given the velocity function v of t. To find the acceleration at t equals 4, we will first differentiate the velocity function that's given. So if v of t is the natural log of t squared minus 3t plus 3, v prime t is 1 over t squared minus 3t plus 3 times, and then we multiply the derivative of this, so 2t minus 3. Then the acceleration function, or v prime t, is 2t minus 3 over t squared minus 3t plus 3. We will then substitute 4 into t. So a of 4 is 8 minus 3, which is 5. 16 minus 12 is 4, and then 4 plus 3 is 7. So we know that the answer to part A is 5 over 7. Next, we are told to find all times t in the open interval 0 to 5, at which the particle changes direction. The position function s of t is the location of the particle at time t. To find when the particle changes direction, we must find when s prime t is 0, and that's when v of t is 0. When the particle moves right, the velocity is positive, and when the particle moves left, the velocity is negative. For the velocity to change symbols, and I mean when it changes from positive to negative or negative to positive, it must go through 0 at some point, and that would be the exact moment the particle changes its direction. We are given the velocity function, so we solve for t when the velocity is 0. E to the power of 0 is 1, so we know t squared minus 3t plus 3 is 1. Factoring this, we get t minus 2 times t minus 1 equals 0. So we know velocity is 0 at t equals 2 and t equals 1. This is the answer to the first part of the question. Now we are told to find in which time interval the particle travels to the left. When the particle travels to the left, the velocity must be negative because the position on the x-axis on which it is moving along is getting smaller. We just found a time when the particle changes direction, so now we just have to find where in between those times have a negative velocity. I like to use this diagram to solve. The numbers that are right above the line represent the values of v of t, and the numbers that are right below this line represent values for t. We know the interval is from 0 to 5, and the velocity is 0 when t is 1 and t is 2. Now we substitute any number of t in between these intervals into the velocity function and check for the resulting symbol of v. So starting with this interval, when t is between 0 and 1, I'll choose 0.5. V of 0.5 is 0.5596. The resulting velocity is positive, so we know velocity in this interval must be positive. Moving on to this interval, when t is between 1 and 2, V of 1.5 is negative 0.2877. The resulting velocity is negative, so velocity in this interval must be negative. Moving on to this interval, I will choose t equals 3. V of 3 is 1.0986. The resulting velocity is positive, so velocity in this interval when t is between 2 and 5 must be positive. So now we can conclude that the particle moves left in the time interval t is in the time interval t is between 1 and 2. Next, we are told to find the position of the particle at time t equals 2. Knowing the fact that the integral of the velocity function is the position function, we can solve for the position using v of t that is given. We will do so by defining s of t using the integral of v of t. Suppose you are given a function for f prime x and an initial condition of f of a equals b. Then the y value of f at a specific value x would be b plus the integral of f prime t from a to x. We change the variable inside the integral from x to something different, t in this case, because our upper limit is x, and it would be incorrect to have the same variables there. But just think of f prime t as f prime x. I like to think about this whole thing in this way. B plus and f prime x, the integral of f prime x is f of x, and according to the fundamental theorem of calculus, we get f of x minus f of a. And we know that f of a is b, so just replace that and we are left with f of x. This is just one of the many ways you can think about it. We were told in the question that at t equals 0, the position is 8. So applying that to this problem, s of 2 is s of 0 plus the integral of the velocity function from 0 to 2. We know s of 0 is 8. Use your calculator to solve this and you should get 8.369. So the position at t equals 2 is 8.369. In part D, we are told to find the average speed of the particle over the interval 0 to 2. The average speed of an object is the distance that it traveled over the time that it took to travel that distance. In this scenario, that would be s of 2 minus s of 0 over 2. And since we do not know s of t, we will use the given velocity function. the integral of v of t is s of t. And when we set the upper limit to 2 and lower limit to 0, that would be s of 2 minus s of 0 according to the fundamental theorem of calculus. And we must not forget to divide this by 2 because it took 2 seconds to travel that distance. So the yellow part here corresponds to the integral here, and the blue part here corresponds to 1 over 2 here. We should also put an absolute value over v of t inside the integral, because speed is the absolute value of velocity. And in the question, we were told to find the average speed. Speed and velocity are different in that velocity gives the direction of the particle while speed does not. So writing it out, it should look like this. Type this in your calculator and it should look like this. To type absolute values, just simply enter APS parenthesis, and inside this parenthesis type whatever you want to find the absolute value of. When you hit enter, the answer should be 0.371. So that's the answer to part G.